First question for you guys. What's a factor? What's a factor in math? What's a factor? Dylan. Guesses? I tell you what, how about I do this? There's something up there that's a factor. What is a factor? The 3 and the 2 are factors. In a multiplication problem, the two numbers you multiply together are factors. So these are factors, and this is a product. Okay? So we're going to talk about factors today and a little bit of prime factorization as well. Whole numbers that are multiplied to find a product are called factors of the product. Number is divisible by its product, or by its factors, okay? So, if I asked you the question, what numbers are 6 divisible by? That means, what numbers can you divide 6 by and get a whole number? What are some numbers that I can divide 6 by and end up with a whole number answer? 3, what else? 2, what else? 6, what else? 1. Okay? That's fancy. But they're also not going to, it's not going to show you the 6 and the 1, but that is also possible. So you're going to be asked to, at times, list all of the factors of 16. That means you have to figure out all the numbers that 16 can be divided by. First of all, here's what I like to do. I like to make like a little rainbow, if you will. We got a 1 and we got a 16, right? We know that 1 and 16 go together because 1 times 16 is 16. Give me another, let's just work up the line. What about 2? Does 2 go into 16 evenly? Sure does. How many times? 2 and 8. Great. Does 3 go into 16? No. What about 4? 4 does. How many times? Oh, 4 goes by itself. Okay? Now, here's a helpful hint. Like they just said, when the numbers begin to repeat themselves, you are done. When you get to 4 times 4, you're in the middle, right? And you're to 16. You're done. Once you've found, you start at 1 and you go to 1, 2, 3, 4, 5, 6, 7, and you keep building up. Once you get to the one that's in the middle, 4 times 4 is 16. You're done. Show you what I mean. List all the factors of 19. See, 1 and 19, right? Does 2 go in there? Does 3 go in there? Does 4 go in there? Does 5 go in there? Let's just think about this, though, for a second. 5 times 5 is 25. We're already over 19, right? We're done. Because 4 times 4 is 16. We're under 19, so we'll go to the next one. 5 times 5 would be 17. Or, I'm sorry, 5 times 5 is 25. So there's only 2 factors of 19, 1 and 19. Did you know that there's a special name for a number that can only be multiplied or that can only be divided by itself and 1 evenly? Do you know what it is? It's called a prime number. A prime number. So let's list a few prime numbers. 1 is prime. What about 2? What can you multiply together to get 2 other than 2 times 1? 2 is prime. 3 is prime. What about 4? 4 is not, because you can multiply 2 times 2 to get it, right? What about 5? What about 6? No, 2 times 3. What about 7? Yes. What about 8? I'm going to tell you right now, all the even numbers can be definitely be multiplied by 2. So we'll just throw out all the even numbers right away, right? So we're done with that. So we got 1, 2, 3, 5, 7. We know 8, not 8. 9?
Yes.
No, because 3 times 3 is 9. So not 9. And we know 10 because 10's even. What about 11? 11 is prime. Instead of yes and no, why don't you say prime or not prime? Okay? So we know 11. 12, not prime. 13, prime. 14, not prime. 15, not prime, because 3 times 5. What about 16, not prime? 17? And we also said 19, for sure. 20, not prime. 21? 7 times 3. What about 22? No. 23? Prime. 24? 25? 5 times 5. 26? 27? What is it? 9 times 3? Yeah, okay. 28, not prime. 29? 29 is prime. Notice they're getting farther apart, aren't they? Before we had 1, 2, 3, like all right in a row, and then 5. Then we were just doing like only 2 apart, 3 and 5, and then 2 apart, and then 2 apart, 2 apart, and now all of a sudden we're 4 apart, and then 2 apart, and then 4 apart, and now this one's 6 apart. They're getting farther and farther apart because the bigger the number you get, the more possibilities there are. Correct? Does that make sense? The next one is 31. 33, no. 35, no. 37. Not 39, not 41, or 41. 41. Okay, and so on. Anyway. Whew. That's a lot. Okay, factors of 12. We're going to list the factors. 1, 12. What about 2? 2 and what? 6. What else? 3 and 4. Those are right next to each other. We're done. We're halfway there. Right? If you want to do this to help you remember and show you what goes with what, please do so. Ha! 1 and 11, we already talked about this one. You're also going to be asked to write numbers in different ways. You're going to say, what are different ways to write 12? Well, 1 times 12, 2 times 6, 3 times 4. You can also break it down even further. 3 times 2 times 2. Okay? We also are going to have to do something called write a prime factorization. That means we need to find all the numbers. Did you know here, listen to this, every single number that there is, you can multiply all prime numbers to end up getting that number. What? Watch. 24. And this is how I want you to do this. I want you to do what's called make a factor tree. Okay? Give me 2 numbers, any 2 numbers that you can multiply, besides 1 and 24, that you can multiply together to get 24. 6 and 4. Are any of those two numbers prime? No. Okay? So we still have more work to do. So let's now break down each one of these. What are two numbers I can multiply together to get 6? 3 and 2. Are either one of those numbers prime? Yes, they are. So we'll circle them. Now, 4. Let's break 4 down. What do we multiply together to get 4, Elijah? What? 2 and 2. Are those numbers prime? Yes. We do not stop our factor tree until I have all the numbers on the bottom circled. Okay? Then, when you are asked to write the prime factorization of 24, here's what you do. You take all these numbers, 2 times 2 times 2 times 3. Is that all? That's all of them, right? 2 times 2 is what? Times 2 is? Times 3 is? 24. These are all prime numbers. So every single number there is has a certain set of prime numbers. When multiplied together, they will all equal that number. Now, when you are asked to write the prime factorization of 24, here's what I want you to do. Remember how I like things so pretty? How many 2's do I have? 2 to the 3rd times 3. That's how I want you to write this. Okay? Do you understand that? So, let's do one together on our whiteboards. I want you to write the prime factorization of 45. So here's what we're going to do. You're going to write 45 at the top. This is how you show your work on your homework, okay? So what I'm doing right now is exactly what I expect to see on your homework. Now, please work with me. What are two numbers multiplied together to get 45? 9 and 5. Are either one of those numbers prime? The 5 is prime, so we circle it. Okay? Then, 9 is not prime. What do we multiply together to get 9? 3 and 3. Both of those are prime, so we circle them. Okay? Now, you are going to be asked to write the prime factorization of 45. Here's what I want you to do then. I want you to take 3 times 3 times 5. How many 3's do I have? 2. So we write 2. I'm sorry. Yep, don't make that mistake. 3 to the 2nd power times 5. And that is your prime factorization. Okay? So when you do your homework and it asks you to write the prime factorization, I want to see your factor tree. Do you understand that? I want to see your factor tree, and I want to see it written very pretty. Just like this. Let me ask you this. Do you think that these are going to take up one line on your homework? No. It's going to take up several lines. So don't make the mistake of, when I give you the assignment, of going down the side of your notebook and writing 1, 2, 3, 4, 5, and then actually doing the homework. Okay? Do the first one. Do the entire problem, no matter if it takes up 1 line, 2 lines, or 6, or the whole page. Okay? Truly, if you guys are all upset at the end of the year and you run out of notebook paper, I will find you another notebook, okay? Just please keep it neat. So I'm going to have you do one on your own now. Prime factorization of 28. As most of you came up with, it was 2 to the 2nd times 7. Now remember, 2 to the 2nd is 2 times 2. Right, Hunter? Erase that. 2 to the second is 2 times 2, which is 4, times 7 is 28. Every single number has a prime factorization. Every single whole number, I should say. Let's go at it again. Now, I want you to notice something. Okay? When I watched you guys do this, I had some of you do this. I had some of you go 3 times 12. Does that work? I mean, 3 times 12 is 36, right? That's fine. You can do that. You can do that. And then you can go 3 times 4. This is prime. And then you go 2 times 2. And that's prime. And so you end up with 2 to the second times 3 to the second. And that works. I had other people do this, 36, and you went 6 times 6. Both of those numbers, when multiplied, equal 36. So this is 2 times 3, and this is 2 times 3. Okay? Either way, it doesn't matter what numbers you choose, you will still end up at the bottom of this prime factorization with your prime factorization. Here, I'll give you one more just for fun. How about 72? Okay, 72 is 2, was it 2 to the third? Times 3 to the second. Okay, I want to tell you that the biggest problem that you guys are having when I walk around is that you're forgetting what you guys are forgetting what all the prime numbers are. Okay, so let's just go back to which one had my list of all the prime numbers. If I were you, I would write these down so that when you are doing your prime factorization, prime factorization, you know what numbers to look for and what numbers to circle. If you circle a number that is not one of these, that means it's not prime. These are important numbers to know. Okay? Your homework assignment. And I know it's Friday, but it's how it goes. It's page 171 to 172, 10 to 28 even, and then 40, 50 even. I want you to show work.